Hey, last lesson of the half of the trimester. I don't know. Next, we're going to do the midterm. So we're graphing logs today. We're wrapping this up with the graphs of logs. Here's the issue. There is a parent function, but there's technically one for like log base 2 and log base 3 and log base 4. There's millions of them. But I'm going to show you the basicest parent function, and then we'll talk about the transformations too. So let's talk about the parent function y equals log base b of x. B could be any number, usually an integer though, meaning 1, 2, 3, 4, etc. It could be like a half. Yeah, it could be a half, but it's usually like a nice number. So logs will always go through the point 1, 0, but what they do after that is up to the b. But in general, it's going to go flat. It's going to have an asymptote, and then it's going to go up here through the point 1, whatever the heck b is. So if it's log base 2, this would be the point 1, 2. If it's log base 7, it'd be through the point 1, 7. Sorry, I meant b1. Hold on. The miracle of whiteout, ladies and gents and friends without gender. So b1 is the point it's going to go through. So if this is log base 2, it'll be to the point 2, 1. If it's 17, it'll go through the point 17, 1. And then here's my asymptote. And it's hard to see because it is the y-axis, but there will be an asymptote. I can count. I can write and count and stuff. So it'll look like this. Now, if b is less than 1, it'll actually look a little bit different. So I'm just going to put that on the side really quick. So if it's less than 1, it's going to go through 1, 0 still, but then it's going to hit down here at the opposite of what it normally is. So it'll be 1 over b1. And the reasoning for that is that it actually does still go through at b1. So like 1/2, 1 would be right here. But because it does that, it just goes down instead. So this is if b is less than 1. It'll look like this instead. That's it. Also, b won't ever be 1 because 1 to powers is really boring. It's always 1. And then here's the holy grail that you keep asking me for. So the negative in the very front of the whole thing would be a reflection over the x-axis. A would actually still change our vertical stretch or shrink. We also use the word compression. B doesn't change a thing. B changes the parent function. It's not a transformation. So B changes where this point is up here. It doesn't actually change anything else. I should have thought this through before I started writing this. This negative right here is reflection over the y-axis. This actually matters now. Like it could actually change everything. H is left or right. And like always, it's backwards. It's going to be backwards the whole time. And then K is up or down. Is that going to be super intimidating if somebody comes and just looks at my notes? Yes, absolutely. I might color code it. Who knows? So let's do an example. Okay. So here's what we're going to do today. We're going to do 2 of them. So I just want to make sure you have all the information you need. I'm going to do a line down the middle so I don't reach into that side. So let's do the description first. So the description is this 2 in front is going to be a vertical stretch of 2. Do you need to watch me friggin' write this? No. And then this little baby 2 down here doesn't change the parent function. It's not part of the description. It is the parent function. And then x plus 1 means I'm going to go to the left. Is this left? Yeah, the left by 1. When I do in class stuff, I have to remember it's backwards, but here it's forwards. Okay, so here's what we're going to do. The parent function of log base 2 of anything is going to go through 0, 1, nope, 1, 0, and 2, 1. So it's going to go through these 2 points. That's the parent function, though. That's not with any transformations. But I just said that this was 1, 2, maybe 3, Trying to zoom way in, apparently. Okay, so what I'm going to do is I'm going to stretch this so that way all of the heights are doubled, and I'm going to move it left by 1. So basically, this asymptote that this line will never touch is actually going to be over here. And then I'm going to move everything over by 1. So that's that point. And then this point, I would normally move to right here, but I'm going to double the height while I'm doing it. So it's actually going to be up here instead. Do you have to be perfect at this? No. Can you just go to desmos.com/calculate and plug it in? Yeah. I really don't care at this point. Normally, how I would teach this is I would teach it that it's the inverse of an exponential function. So I would make you find the inverse, graph that, and then graph the inverse, and then you have the log. I don't care that much this year. Don't tell anybody. Shh. It's on recording, I know, but anyways, next one. Okay, so this negative in front is a reflection over the x-axis. It's going to be y. It's going to be y-axis if the negative's in here with the x, but if it's outside, it's x-axis. Kind of backwards. That always confused me when I was in freaking high school. Like, how do I know when it's what? And then down 3. So, but I kept the parent function the same so you can kind of see what's happening here. So, again, parent function says, I feel like Family Feud. Survey says, ding. Do you need to watch me do the graph? No. Okay. 0, 1. Nope. Sorry. 1, 0. I keep doing that. 2, 1. So that's the parent function for specifically for log base 2. And then I'm going to reflect this over the x-axis and then shift everything down 3. I do it in that order. It's PEMDAS. I do multiplication and then I do subtraction. So if I flip everything over the x-axis, it's actually going to look like this. I got more stretched out. It's fine. So there's my reflection over the x-axis. And then I'm going to move every point down 3. So this one goes 1, 2, 3. Oops. 1, 2, 3. And then it still is flush against this axis, though, because there's no plus or minus with the x. So it goes like that. Down 3. Okay. Are you confused yet? Great. Here, let me show you something. Okay, so this is desmos.com/calculator. Not calculate, like I said earlier. This is your bonus for actually watching the video. When I do this, I don't need to use the fancy calculator at the bottom. I can just type in the word log, and see how it went from cursive to being like a function. And then to do base, I'm going to do shift and then the straight line, kind of by 0, and that makes it underneath. So let's say log base 2 of x. Here's the parent function. And if I wanted to graph it so that way I could see what the transformation is, I would do like negative log base 2 of x minus 3. That's what I just did on my paper. See, watch. Where's my mouse? Hold on. Okay, same graph. Same graph. I'm really not mad about it. As long as you're learning, that's what I care about. Okay, so do your homework, and then the other thing that I have for this week is studying. It's not really necessary, but it might help if you're frustrated or scared of the midterm or something like that. So you can do that. Okay. Have a great day. Email me if you're confused. Come to my office hours and ask questions. I got you. Okay, bye.